Hey everybody, going to do a little bit different video this time. Not completely different, but this is what's going on. I'm getting a lot of emails asking me how I do different things, and I try to put together kind of a scripted video, but those just don't work anymore. So what I'm going to do is read all 4 or 5 questions that's been asked of me, and hopefully this will answer most of the emails I get and also be informative to you all. One of the very first things I got was I had posted that I had made kind of my own little decking that went on the hotbed of my 3D printer. Now this is spring steel that I got from Master Car, and this is the PIE material that I got online that is 1 millimeter thick, which means this is like a battleship. Okay, it really is thick. So what I do is I put some rare earth magnets underneath my heated bed to hold this down flat, but I also use some clips around the back side to keep it from moving. The beautiful thing about this with me making all my engines now is that I have to have a repeatable way to pop this material off my bed without screwing the bed up and just costing me time and hurting margin on the motors I'm trying to sell so inexpensively. So I've come up with a method where with this spring steel, it's really tough stuff. It's really hard to cut, so I had to cut it to fit my bed, and it basically destroyed my bandsaw blade, but at least I was able to cut 2 of these out. So essentially this is a cylinder, a half-scale cylinder that goes with my Lerone vintage aircraft engine. And all I do to pop it off is I'm going to do this, and then I'm going to do this, and both my cylinders are off. It's that simple. Okay, now I use some support material inside my cylinders, and that's to hold up the middle of the arc so there's not a little bit of sagging in the middle, and I end up with the 2 cylinder halves that fit perfectly. Now I always print a little bit of a skirt around it, so I make sure that I've got good flow coming out of my 3D print head. For that, I just get my fingernail up underneath it, I pull off the material, throw it in the trash. And one of the things I figured out this last month that's been a real breakthrough for me is I had used ABS juice, which is basically acetone and a bunch of my scrap filament, and it basically is the consistency of milk. I would put this on here, but with this 1 millimeter thick material, it gets, I think, microscopic fissures in it. So it was actually holding it down so securely I was damaging my part when I took it off. So it really became a stressful thing for me to figure out. So believe it or not, what I do is about every 30 prints, I actually take car wax and I'll treat this, let it dry, polish it off, and now I'm going back to the Elmer's glue stick. What's really neat about this glue stick is it's purple. I put it on clear. When I go to rinse this off, it all turns purple, and I can completely wipe it 100% off and then reapply my glue stick. So this material sticks so well to my part that I was damaging parts trying to get it off. And with this being 1 millimeter thick, you're not going to damage it. So what I did was do wax about every 10 to 20 prints, use my glue sticks, and all I have to do is do this, and they pop right off, and I have perfect parts. So that was one of the first things that needed to be answered, and I hope I answered it. Now, design softwares that I use AutoCAD, Fusion 360, CompuFoil, and Simplify 3D. Those are my primary softwares I use to do all my designs and building of my motors. Tools to make my designs. It's taken me literally around 20 years. When I think about my daughter being 16 and when I first got my very first plotter, it's literally been 20 years I've been collecting tools. And tools is everything from bandsaws for wood, bandsaws for metal, my brazing outfit, my welding outfit, the lathe and mill I have, to my 3D printers I have. All those are tools. It's literally taken me 20 years to achieve the level that I can make things myself. Now, that kind of opens the door for the next question is, when I'm designing, how do I know what I can design? And that just comes down to experience and skill. When I look at what I could do originally with a lathe and a mill, took lots and lots of hours to make. And in the model airplane kind of world we live in, things don't have to be as strong as you know, real airplane attachment points and aileron hinges and stuff like that. So what I'm doing right here, even though I wasn't going to talk about this, is I'm designing ribs that's going to go in the elevators of my MSL2 that will be epoxied into the plywood rib, and this will end up being the hinge point for my elevator. For me to mill this or cut it out of aluminum would have taken me forever. For me to draw it in CAD took about an hour, and 3D print it took 2 hours. So this is where 3D printing is opening massive doors. But I guess what I'm trying to say is, when you're designing something, think about the tools you have to actually build it. You know, I could design some really cool things, but I'd have to go out and find a company to build it for me. So I really try to make sure that whatever in my head I'm designing, I'm thinking of the processes of making that in my shop here in my house. It's real difficult. It takes a lot of time. I look at a lot of the failures I've had, and it's because I've pushed my own personal experience at maybe welding or fiberglassing in my molds and my plugs, though I've pretty much figured that out now. So I wanted to answer that. The next thing I needed to explain is, I keep getting people asking me how I test things. And honestly, I don't have a real method to my testing. I'll either do a structural test where I pull something or I crush something. I will do testing where I test the bend moments and things. I just kind of look at, when I'm building something, what I believe from my experience will be the weakest part. And like the other day, one of my friends wanted to know how strong this would be, this pivot point. So I actually put a scale on one side, put my little arm on the other side, and when I got to 300 pounds and this didn't fail, I knew I was good to go. And my scale only went to 300 pounds. So at 300 pounds, I couldn't pull this 3D printed piece apart. Now, I know you're going to ask, this is ABS impregnated with, this is actually a PC ABS blend, which means I print it at about 290 C. I mean, that's really, really hot. And it is the greatest material I've ever used because it's easy to machine, it's easy to cut, it's ABS, so I can still do the acetone vapor bath and smooth it if I wanted to. But because it's a polycarbonate and a ABS blend, it is just stronger and very, very heat resistant, because I actually have to print this at 290 C. Okay? So, another question I got is, in an email, basically I started in November selling my 3D engines online. How many have I sold and what challenges have I had? Well, it's hard to talk about what I've sold and what I've actually shipped, because I have quite a few friends out there that I've shipped engines to for testing. And I've got a half-scale Rhone right now I'm printing out for a gentleman that's basically going to use it for his airplane, but also give me some critiques and hopefully give me ideas on how I could improve the engine. So if you really talk about sales, 100-ish engines, giving them away 15 to 20 engines. So, right now it's paying for all of itself. I'm breaking even or making a little bit of money. So it's been a really good adventure. And really, I started out on this adventure of building my own engines because my daughter's gonna probably cost me $400,000 to go to college. In the hobby, I just don't want to spend any of the money that I make on my real life on my hobby, because the hobby's the least important thing, even though it's a big part of my life. So that was kind of wordy, wasn't it? So let's see. And the last question is that how do I come up with my designs? And that's a question that nobody in the world could ever answer. You put everybody together, and no one's going to be able to answer it except me. Here's how I come up with my designs. I look at everything that's been out there. I've been doing model airplanes for, if I include control line, for over 40 years. And I look at everything from control line stunt that I used to do to control line scale. I look at just some of the things I invented to try to make them fly that didn't fly. I look at things that I invented that flew very well. So I guess what happens is, we all love the look of a P-51 Mustang, or we all love the look of a B-17 bomber, or we all love the 1920s and 30 air racers, the GBs. And when I look at a plane I designed from scratch, a lot of it is, what would have it been if I built a full-scale airplane just to have fun with? And that's what the MSL-1 and the MSL-2 are. Now, when I'm building a 180-inch Mosquito or my 160-inch C-130, I'll try to copy those as close as I can to the full-size airplane. But where I'm sometimes an idiot is I want to put every system I can cram into it, and it's a mental defect I have. The C-130, I've told everybody from the beginning, it has a really high chance of, I'm not saying crashing, but becoming a hangar queen. The systems in the C-130, from the Fowler flaps to the the jack screws that operate the landing gear, to the doors and the track system for dropping Humvees, all of those systems, if any one of those don't work right, the plane will become a maintenance hog. So, I keep looking at what's going to be my next big project, and I whittled it down to a 180-inch Mosquito, or the about 185 to 190-inch T-28. Problem with T-28 is building the big canopy. I'll have to build a big plug. I'll have to build a big furnace in my garage, and to actually melt a 16th plexiglass canopy for a T-28 that's almost 200-inch wingspan, it will be the biggest challenge. And I won't build the airplane until I probably build the canopy first to make sure I can do it. So, I do have 10 other airplanes I want to build before I die. One is the Bone, and the other one is, the Viking, the big Viking behind me on the wall. But I also want the next airplane to be easy and fun to fly, because I'm tired of killing myself on a plane like the C-130 that takes 6 years to build. So hopefully I've answered all the emails and gotten everybody up to speed. When I look at some of the intricacies that I'm building on some of the engines that I'm selling and the vibration testing I'm doing with them, that takes a lot of time, which I have no time. Okay, the MSL-2 will be flying at CEF, and I'm getting ready to do a video just on CEF to let everybody know how cool CEF is. And quite frankly, if you're in electric motors and electric airplanes and you don't go to CEF, there's something wrong with you. I mean, deeply, darkly wrong with you. So, thanks for watching my videos, and I hope you enjoy them. I hope I'm answering all the questions I can. And a couple of videos I'm working on doing right now is one, like I said, on CEF, because I want everybody to get jazzed up about CEF coming up. The other video is I'm trying to put together how I'm doing some testing on vibration testing parts and pieces in my kits. And I also have a video on the actual software I use, which is the Fusion 360 and the Simplify 3D. So thanks for watching my videos. I hope you all have a great day. I hope you find these informative. Keep the emails coming. And have a wonderful day. Take a kid flying. Just enjoy yourself. Keep on trying, everybody. Thanks. Have a great day. Be safe.